it'd be a lot tougher, okay, to get that number right. It'd be tough to even be within, you know, a number or two, okay? So over here we've got more variation, okay? The numbers are more spread out. Visually, the numbers are more spread out here, spread out in this graph. Okay. So the variation, we can even talk about just the spread here. Sometimes when you have lots of numbers, okay, it can be tedious to try to put a dot for every single one, okay? And so instead of drawing a dot for every single one, okay, so let's say instead of 10 people from the factory, let's say I randomly picked 100 people, okay? So maybe we go to like Toyota factory or something, okay? Or Nissan factory in Alabama, and we ask, you know, how many children do you have, okay? And we survey 100 people. We don't want to be drawing dots for every single one, okay? And even if we used a computer where it doesn't care if there's a lot of dots, the dots might be difficult to. It might be difficult on the eyes. So in cases like that, we can get the exact same data, or pretty much the same kind of information, but we can represent it with a histogram. Okay? And so I'm going to just turn this dot plot into a histogram. Again, the first thing I do in any of these things, I draw a number line. How many people do I have represented at 0? I have 7. So with the histogram, I draw a vertical axis. Okay, and now I'm going to draw a bar centered at 0. Okay, that is 7 units high. At 1, I have 2, and at 2, I have 1. Okay, and here I've got a histogram representing the same exact information here. Is that okay? All right. Sometimes you can have histograms where you have multiple numbers represented by one bar. Okay. So let's say, for example, we asked how much do you weigh? Okay. We asked 100 people, how much do you weigh? Some people said, I weigh 135 pounds. And someone says, I weigh 142 pounds. Someone says, I weigh 144 pounds, okay? Well, we might not want to draw a bar for one, you know, maybe there's one person who weighs 143 pounds and another person who weighs 144 pounds, okay? We might not want to draw one bar for each person there, okay? Instead, I might say, well, how many people weigh between 140 and 150 pounds? So basically 140 to 149.9, and maybe there's 10 people, okay? Then I will put all 10 of those people together in one bar, and I will have a bar 10 units high for all the people who weigh between 140 and 149 pounds. Does that make sense? Okay? And so for something like that, so again, this is called a histogram. Alright, and this is where each bar represents a range of measurements. So maybe okay, so again, you draw a number line, and a histogram has a vertical axis showing basically how many people are in that category, and maybe it looks something like this. Okay, so in a histogram like this, and maybe my bars aren't that great, but how tall is this bar right here? So if I put it, maybe I'll put a 4 here. Okay, so what does this bar that's 4 units high represent? Yeah, so that's saying we basically have 4 people who weigh between 120 and 130 pounds. So basically between 120 and 129 pounds, I have 4 people, okay? And then I also have 4 people between the weights of 130 and 139.9. And then here I've got 6 people between the weights of 140 and 149.9, okay? So how many people are represented in this histogram? This one's on, let's say, is 2. Yeah, I have 35 people total. Okay, is that okay? All right, and that's just what this histogram represents. Okay, so what if I said what percentage of people weigh less than 120 pounds? How would you calculate this? Three divided by 35, right? I've got 3 people who weigh less than 120 pounds out of 35 people total, so then I would say 3 divided by 35, and that would be like 8% or 9% way less than 120 pounds, okay? So this is a histogram for the weights of people, okay? I have 35 people, and there you go. Okay. Now, when we describe a distribution, got just a few minutes left. Okay. Maybe instead of drawing bars, we can kind of I'll still draw bars here. Okay. Sometimes we'll talk about the shape of a distribution. Okay. So if I drew a histogram, and it looks like this, okay? Maybe this is the height of people. Okay. Again, everything, you're supposed to draw a number line, and so something like this, okay? So maybe this is the heights of people in I don't know, heights of women on some in some class. Okay. What this tells me is that most of the women are, you know, in this range of heights, 64, 65, 66 inches, okay? I've got some people who are taller, some people who are shorter, but there aren't that many women who are very tall. On the other hand, I don't have very, very many women who are very short, okay? This, we call this symmetric. Meaning, if we call this the middle, so I have about the same number of people who are much taller than the middle, as I do who are much shorter. So that would be a symmetric shape. Is that okay? All right. We can have skewed shapes. All right. This is actually an example of something that's skewed. Okay. Something that's skewed might look like this. This would be, we call this skewed right. Okay. Or skewed right could look also look like this. Okay, this is also skewed right. Okay. And then sometimes we're just so lazy, we don't even draw the bars and we just draw this curve. Okay, when we say these are all skewed right shapes. And if you need to remember which side, what this is skewed right, okay, because on the other hand I've got skewed left, and it's basically just the mirror image. This is skewed left. Okay. If you need help remembering which side is skewed right and skewed left, just imagine cutting this out and then trying to cook some meat on it. Okay, which side would you use to skewer the meat? You'd use the pointy side. So you'd use the right side over here, or the left side. Okay, if you were gonna stab someone. Okay, skewed right and skewed left.
So it's the opposite?
What do you mean the opposite?
Like, this is your left side, which is skewed right. Oh,
No,
just kidding.
the skewer side is on the right, okay? The skewing side is on the left. Okay, that's why skewed right and skewed left. Okay, what does it mean to be skewed right? So it means I've got a lot of people over here. This is kind of the bulk or the middle. A lot of people in the middle. Okay, so this might be the middle. Or kind of like the average zone. So lots near the middle. I have a few people with values that are much higher than the middle. Okay? Can you guys see that? So if I go to the right, that means the values are larger, because number lines get larger as we go to the right. So I've got some people who are much higher than the middle, but if I go that distance below the middle, I hardly have anyone. Okay? So lots near the middle, some who are much higher, than the middle. Okay? But no one who is much lower. Okay? I know we just have a couple minutes left, but I just want to talk about this, okay? So skewed right, things that might be skewed right. Weight, human weight, okay? So what do you think the average weight of a female in the United States is?
120.
Yeah, it's about 145, 150, okay? Something around there, okay? Average adult female in the United States, around 145, 150, okay? It's like right at the borderline between normal and overweight, okay? BMI 24.9. Okay. Are there women who weigh 300 pounds?
Yes.
Yes, okay. Not very many, but there are, okay? How much higher than average is a woman who weighs 300 pounds? If the average, if we say average is 150, how much higher than average is a woman who weighs 300? She's 150 pounds above average, okay? How much would a woman be if she was 150 pounds below average?
0.
0, right? If average is at 0, and we have, if we go 150 pounds above, we're at 300. If I go 150 pounds below, I'm at 0, okay? So, do we have women at 300 pounds? Yes, not very many, but we do. Do we have any women who are at 0 pounds? No, okay? It's impossible to be an adult female who weighs 0 pounds, okay? You have some women who weigh a lot less than average, okay? Maybe 90 pounds or 80 pounds or something like that, okay? But in terms of, in the overall scheme of things, it's hard to be alive under a certain weight, okay? On the other hand, you can go, there's room to weigh more, okay? And so that would be an example of something skewed right, okay? Skewed left, on the other hand, is just the opposite, meaning we'll have some people who are much lower than the average, okay? And most people are kind of in this general zone, but we have some people who are much lower than average, and then nobody too much higher than the average, okay? So something like that might be, not height, height would be symmetric, like how long somebody takes, or maybe the score on an exam, okay, the score on an exam, okay? So maybe the highest score you can get on the exam is 105%, okay? Most students will probably score between 70 and 100%, okay? And so the average being somewhere around 80 or something, who knows, okay? But will I have students who score 20%? Yeah, unfortunately, yes, okay? So somebody who scores 20% would be like 50 or 60 points below average, okay? Can a student score 60 or 50 or 60 points above average? No. If the average is like 70 or 80 points, trying to get 60 points above average would take you to 130 or 140%. That's just not possible on the test. So usually test scores are skewed left, okay? Most students do in this okay to well range. Some students do really terrible, okay? And so they are on the lower end, and that would be skewed left, okay? One more thing, sometimes we have multiple peaks, okay? So all of these things have one peak, we call this unimodal. Sometimes we have 2 peaks. This would be called bimodal. Okay, and if it's got any more than that, we usually just call it multimodal. Whatever, okay? So if we're looking at heights of people, unimodal, most people are average, some are much higher, some are much lower. Bimodal, okay? Just hang with me for this last bit. Okay, bimodal, again, we're thinking of a numeric distribution, okay? Something that's numeric, but has 2 distinct peaks, okay? So that would be something like, maybe like testosterone production, okay? So in humans, everybody creates some testosterone in their body, okay? But it's a fact, men create more testosterone than women, okay? But you've got some women who create more testosterone than other women, okay? Some women who create less testosterone than other women, okay? You've got men who create more testosterone than other men, men who create less testosterone than other men, okay? So you're gonna see distinct peaks in the distribution of this, okay? So someone over here, most likely male, produces lots of testosterone, okay? Someone around here would be kind of the average amount of testosterone production for men. Over here would be kind of the average amount of testosterone production for women. and someone down here, probably female who just produces less testosterone. Or, you know, there's medical cases where, you know, sometimes you have a male for some medical reason produces very little testosterone, or sometimes you have a female for medical reason produces a lot of testosterone. But in general, this peak represents something for women, this peak over here represents distribution for men. And when you combine them, you see these two peaks. Okay, does that make sense?
Yes.
Okay, so you got a little bit more reading to do. That goes into this in a little bit more detail. Do your homework. Again, I encourage you to do it a few times this week. This week it's easy. You can get away with doing it all at once, but don't make a habit of it.